So we know now that quadrilaterals are nothing but anything that has four sides. For example, this, and this then becomes a quadrilateral. So the point is that this you can change. I mean, any shape it can take, but the point is that it has to have four sides: 1, 2, 3, and 4. Now, the types of quadrilateral, before we discuss, you should understand why you are doing this, and you are actually studying this because many things in future will be actually where you'll have to study four side figures. For example, this is a common map of a house, and you will see many places where the four-sided figures are there. This is, let's say, a room plan. This has four sides, this has four sides, therefore this again has four sides. So studying quadrilaterals, therefore it's very important because number of places you will be dealing with such four-sided figures. There are two broad definitions of quadrilateral. One is simple and the other is complex. Now the definitions of simple and complex, we will deal this much in detail in later lectures, but right now the definition for simple I'll just give you is not self intersecting, whereas the complex is one which is self intersecting. So self-intersecting or not self-intersecting, as the name implies, means something that cuts itself, then it becomes self-intersecting. And something which is not cutting itself becomes, when the four lines do not cut each other by any way, then these are not self-intersecting. We'll discuss this thing in detail later. Right now, let's focus on the simple one. Is basically divided into two categories: convex and the other is concave. Now, as the name implies, convex, if you recall, you will study in physics or science subjects that something, let's say mirror, if it is convex it bulges out. Like this is a mirror which is convex, and this is the silvering side. Whereas concave mirror is this. There is a depression. When you have inside, there is a depression. Whereas something bulging out is the convex. And when there is a depression, then it is concave. So when you have in quadrilateral something bulging out, it is convex. And something where there is a depression, it is concave. For example, look at this. It is this quadrilateral is bulging out on all four sides, so that's why it is a convex quadrilateral. Whereas in concave, you look at this, these sides BC and CD is actually going in, you know, the way you saw the mirror, concave mirror is going in, so this becomes in concave quadrilateral. So when there is a bulge on all four sides, it is convex. When there's a depression on one side, it's a concave quadrilateral. And we'll be discussing about complex quadrilateral later in other chapter. So here is a general figure which explains all kinds of quadrilaterals. Note, all have four sides. See, wherever you go, well, we'll explain this later because these two actually are representation of this one and this one, the complex category. But in general, any quadrilateral is either complex or simple, and I have already explained simple consists of convex or concave. Concave example I have given. Now convex, you have many other kinds of subdivision, which is tangential, trapezium, cyclic, isosceles trapezium, right angle trapezium, parallelogram, kite, rhombus, bicentric, rectangle, three sides equal trapezium, and the square. And I'll explain these one by one now. Now look at this. This is what you will encounter many a times, this particular kind of quadrilateral, which is parallelogram. when opposite sides are parallel to each other, like this is parallel to this and this is parallel to this, then these are called parallelograms. And under this comes rhombus, bicentric or rectangle. We are interested in, let's say, rectangle. Rectangle is that kind of a parallelogram which has opposite sides parallel, but the angle here is 90 degree. Note the angle here could be anything, but when it becomes 90 degree, then the parallelogram becomes rectangle. Similarly, if the parallelogram have opposite sides parallel and also equal in length, for example, this parallel side is equal in length to this one and this is equal to this, which means all sides are equal to each other, all four sides are equal to each other, then that kind of a parallelogram becomes a rhombus. So all sides equal is, and the sides parallel to each other is a rhombus. And the rectangle is the one where this is 90 degrees, sides may not be equal to each other, but when sides become equal like this, all four sides equal and also angle is 90 degree, this one, then that kind of rectangle becomes a square. So you can say square is basically a special rectangle with all four sides equal, and rectangle is a special parallelogram with angle 90 degree, and parallelogram is a special kind of quadrilateral with opposite sides parallel. Now this will lead you to the definition of trapezium. When two sides are parallel to each other, for example in this and this are parallel to each other and this are not parallel to each other. When two sides are parallel to each other, then it is a trapezium. So trapezium, any figure which has two sides parallel, at least two sides parallel, become a trapezium. But parallelogram also has two sides parallel. In fact, both opposite sides are parallel to each other. So then parallelogram also becomes a special case of trapezium, where not only opposite sides, one side, but also the other sides are also parallel to each other, and they all form convex quadrilateral because all are bulging out, as I explained earlier. Another kind of convex quadrilateral is called kite. Now in kite you have two sets of equal sides. Note this, adjacent sides. Adjacent is an important word. This is adjacent to this and both are equal. Similarly, this is adjacent to this and this is equal to this. So when the two sides here are equal and the other two sides on the other side, then they form kite. Now right angle trapezium is a special kind of trapezium with angle 90 degree here. An isosceles trapezium is the one which has base angle this equal. So this is also a kind of a special case. Three-sided equal trapezium are where the three sides are equal. This and this are equal. And now you can see that still some of the figures I have not discussed. For example, this bicentric or tangential I have not discussed. A cyclic, we will be discussing this later when we go to advanced concepts. But what you have to remember is that quadrilateral basically consists of two varieties, complex and simple. Complex is what you will study later on, but the simple ones are the one where there is no intersection of lines, and they consist of two varieties, convex and concave. And convex has many varieties, which has been explained to you during this lecture.